How's it going?
I hope chicken butt.
I'm trying to learn harmonica this winter break. I'm gonna get a harmonica and get really good.
You're gonna play a harmonica?
Is this gonna be like an easy class? Like I couldn't play anything that wasn't on the class.
Are any of my classes ever easy?
I don't know. Please don't make me think.
I'm gonna play a haunting song every time I walk out of your test, Dr. Joe.
Numerical.
We're gonna do problems today.
That's what I meant.
Yeah.
That was the way down.
I'm gonna give you an assignment today.
Over fall break?
Yes.
You're kidding.
No.
Dr. Joe! That is so mean!
What?
He's giving us an assignment.
I have to read like 100 pages of a book.
Yeah, I did read the first round.
And I have to write a 5-page paper for that same class.
And I have a test on
How dare teachers feel
Yeah, I'm gonna
like
make
they
sure
should
to
get
make
homework.
it down this time.
I have a program
Mike,
next week.
will you stop whining?
No, I will not.
Program 4 is already due next week.
I thought so.
When's it due?
I don't know.
It's due sometime next week.
Next week? Are you guys sure?
Is that it?
I don't actually.
Is that the homework?
That one takes
Yeah.
a while. I don't
For the
think-
homework?
I
If it's
skipped
due
some.
Those are the, yeah, that's all the problems that are on the homework, yes.
Dr. Joe, is our test really on Tuesday?
Thursday.
Thursday.
Okay, I definitely haven't written
Program
down
4 is
Tuesday.
due in 2 weeks.
Wait, when do we have a test?
Next week.
I haven't written down the wrong day.
Next week on Thursday.
Next week on Thursday or Friday.
So this would be Monday or
Maybe
Wednesday?
Friday.
That'll be due when you take your test.
Saturday?
Oh, that's plenty of time.
Didn't say I was gonna be due Monday, did I?
I was thinking Wednesday. I was still upset about it. But that's okay, it's only 5 problems. Usually you time like 14. I'm
Do
not
I
wrong.
want to take it Friday or
That probability
Oh my god, this is so long.
This is nice and small.
You know
They
why
should've
I
been,
written on the
yeah.
wrong day? Because I'm looking in the wrong month.
I like it.
Oh.
Assignment.
There we go. There we go.
All right, so
Wait, that's what's wrong.
you're not ready.
Do we have to get out our packets today, or?
Yeah, I was gonna do a couple of problems off the big packet today,
Wait,
but these are out of the.
Like I should get my packet out, or no?
Well, I'm gonna do. I mean, I can just write the problem down. You don't have to get it out if you don't want to.
I don't even know what that means.
I like that better.
Did you just come and take a picture of those homework and just
Yes.
Who?
Okay.
Yes, it is absolutely. And turned in his homework and took a picture of the homework and left. Yes, that's absolutely what he did.
You should have waited till the end of class to tell us what the homework was.
Was it?
Why doesn't he just look at your video?
You got me on that one. It's being recorded. It's on the video. So.
Why not just go to
We all just
right here? I don't know.
Alright, well then. I'm
Maybe
not
he's
too-
going
No,
home.
I'm kidding. I'm kidding. I would never say it after your class. Those are important.
Is there? Oh, thanks.
Well, I usually don't know what's going on.
Yeah.
I can't skip those.
That's why I have a hard time skipping. I wish I could skip.
Every time I miss a Dr. Joe class, I always regret it.
I've done that a couple of times. I did that a couple of times as an undergraduate. I walk up to the door and I'm like, nope, can't today. Turned around and walked off.
I did that yesterday. I did that yesterday in computer science. Forgetting
What's that?
I didn't have class.
Accounting at 6 o'clock, and I stayed home for like 3 different times.
Yeah, I can see that.
That's not counting the times you canceled before.
It's funny.
You're stuck here.
All right. So, I made an error last time in notation. I hate when I make errors, but I made an error last time in notation. I know.
Tick mark.
It's a tick mark.
I bet you don't miss that, do you?
It's okay,
But the
Dr. Joe, we forgive you. Notation is hard.
Notation is hard, yes.
Especially
So-
when it's all the same. It's
All
all
right.
different.
Say that again?
Do you miss numerical, Dr. Joe?
No.
Are you
I
off?
like the students, but I hated the material.
And you got mad at me yesterday for saying that numerical was the worst class ever.
That's not very nice, Grace.
You think numerical was
You
the worst
agreed.
class ever?
Yeah.
I didn't think it was the worst class
I like
ever.
It wasn't the worst class ever.
What's the worst class ever?
How about worst math class?
Probability.
Okay, worst math class.
Um,
No,
Yeah,
because probability makes sense. Numerical is just like.
Oh, I just thought
I
in
liked
terms of
numerical. I thought it was
difficulty.
interesting.
We do? Yeah.
I was every-
There's a lot of good things that you can do with it. I just,
I liked making this.
you know what? I would have liked it a lot better I would have liked it a lot better had I got the dang technology to work more
Yeah.
consistently.
Technology is hard.
Geometry is the worst math.
Especially on Milliken's
I don't like
campus.
geometry.
The only thing I remember
I've
from
never taken a
homework.
geometry class.
I can take it.
You
What?
can take the fall and Dr. Stickles.
There's a
Nah.
geometry class here?
It's for the
College geometry.
Isn't it funny that we
Are
call
you gonna take it?
her Dr. Stickles?
I said I hate geometry.
It's from
geometry was the first class where I walked into a
She doesn't like going
class.
by her.
I'm prepared. And walked
I always
out.
tell people, I always call her Mrs. Dr. Stickles. The other
Mrs.
people.
Dr. Stickles?
You have to. It's like you have to differentiate between you two, the people that aren't in the math department.
Yeah.
You know, like
That reminds me of this gym teacher we had who's like 22, 23 back in high school. And we literally just called him Mr. PE Sir because he wanted us to call him like Mr. Hemming,
Mhm.
his name, but everyone knew him as Austin.
Yeah.
So we compromised. He hated it.
Yeah. Of course.
Mr. PE Sir.
I can see that.
Final project.
All right. So we talked about continuously. I gotta get the words right too, because there are.
I had my desk replaced.
There's. I told you that a lot of what we do in this class is a vocabulary lesson, and sometimes I mess up the vocabulary too.
Yeah.
So a continuously.
When did you mess this up?
I messed it up last period.
Last period.
Yeah.
When did I write it down? I didn't write any words down. Yeah, I don't see any words that I wrote down.
We did problems. I talked about a continuously paying increasing annuity.
The IA, the line.
Yeah. Except that I made a mistake when I did the notation.
Oh, okay.
Okay, so this is you pay continuously and then the amount of payment each year bumps up. That's continuously paying increase annuity. Here today we're going to talk about continuously increasing annuities, which are different, and the notation I gave you is for the continuously increasing annuity, not the continuously paying increasing annuity.
That's what the difference is.
That is a lot of words, I
There's
know.
just a bar over the A, isn't it?
Is this just a bar over the A?
That's
Yes,
what
there
I
is.
said.
Yes, you're right.
Are you saying that the IA bar?
It should be IA bar, and I put a bar over the I too. That's a different symbol.
I didn't.
It's okay, nobody blamed you.
I blame me.
But I don't, so it's
It's
a
a
tick.
tick mark.
It's a tick mark. It is a tick mark.
But we're already getting a pizza party, so it doesn't matter.
Are we doing that this semester?
Of course. Why wouldn't we do that?
Dr. Jelly Smile over the bus.
Sponsored by Del Carmen's.
Well, that's right. All right. So this was annuity due, and then NV to the N, and it was over delta, right?
So
Yeah.
that's
All right. So remember that this is like your. It's essentially the same as your increasing annuity formula regular, and the idea is essentially the same. The annuity pays 1 in the first year, 2 in the second year, 3 in the third year, and so on. Except that the 1 is spread out over the whole first year, and it's done so continuously. And then the 2 is spread out over the whole second year, and it's done so continuously and up the line. Okay? The really weird part about this is that we're spending time on this, and there's so few problems. Literally, the stuff we're talking about today, the review manual that I pulled problems out of had 5 total questions over it. And they were all old exam problems, 5 total in the whole review manual. So, to show you how little it actually is done on the exam,
will be like 1 question.
it may be 1.
If even.
If even, yeah.
Nice.
Yep. So
So we don't have to learn this.
depends on if it's the make or break question, right? Gets you to the pass level or not.
Yeah.
Yeah. All right. So this is continuously paying increasing annuity. All right. We'll talk about continuously increasing annuities here in a little bit. All right. So what we're going to do, and this is more words, and again, I want to make sure I get the words right because I've already messed up once, right? We want to talk about continuously varying. What's wrong?
I posted that I applied to like 17 instances for the summer.
Wow.
I heard back from 3, and 2 of them were no's.
Oh.
To be fair though, the one I sent the wrong cover letter, so that was my bad.
Oh, yeah, that'll do it.
And then the other one was that weird one that just like didn't look good.
Gotcha.
Hey, but one was yes.
Well, it was an interview.
I haven't started it.
I went back at it.
You're already ahead
Okay, so we've talked about force of interest, which is continuously compounding interest rates, but the continuous compounding is a fixed constant interest rate, right? We've also talked about continuously varying, continuous payment streams, but the payment stream stays constant for whatever period of time, right? It could be continuously paying annuity with a level amount each year. That was the A bar, right? Which is 1 minus v to the n over delta. That was the A bar. Or we just talked about continuously paying increasing annuities, which was level for a level amount for the entire year, spread out continuously, then bumps up, spread out continuously, then bumps up. It does discrete bumps, right? What we're going to be talking about here is changing both of those ideas for constants to varying. Now, if you watch the videos, which I meant to ask you to watch the videos for today, I forgot. But if you watch the videos, the formula that we get is derived in there. It's actually me talking this time in those videos. It's very
I'm surprised
exciting.
there's a derivation.
Huh? It's the best part of math. I'm saying. All right. So, what's that?
So it's subjective.
Yeah. Mathematics is about proving things. That's what mathematics is.
The
So.
best part of math is getting the right answer.
All right. So let's say we have a payment stream, and I want to try to use the notation they use in the book. They use PMT sub t because that's, I don't know, abundantly clear. That's what you would use for the notation. So the idea here is that at time t, a payment is coming in at that amount. But again, it's continuously varying. So for example, if your payment at time t was t, at time a half, the payment would be a half. At time 3/4, the payment would be 3/4. At time 2, the payment would be 2. It's just continuously varying the whole time. Okay? Our force of interest will denote with a delta of t. I like the function notation better than the sub t notation personally for that. But again, that's giving you the amount, the interest rate at time t. Again, continuously varying. The stuff that we've done with force of interest before has been a constant. So going back to, I'm not going to do the derivation in here because I don't want to spend the time on it because there's a lot of time to spend on so few problems that could actually pop up on the exam. But going back to Calc 2 ideas, the way you deal with continuous ideas to start with is to divide it up into chunks. Look what happens on the smaller chunks if you assume constants. Add it up, take a limit, recognize it's going to be an integral, right? When you do this in this case, there's going to be two spots where you're going to get an integral because you've got two things that you're chopping up. I've got to chop up this continuous payment stream, and I have to chop up this continuous force of interest, right? So in this formula, there's going to be two integrals, okay? So here's how it works, and actually one of the integrals is going to be inside the other one, okay? It's fun stuff. All right. No, it's not a double integral. There's going to be an integral in one spot, inside an integral in another, but it's not a double integral. All right, so the present value will be, you're going to integrate from, I'll start at 0. You could start anywhere, but if we think about present value, so value times 0, I'll integrate from 0 up to whatever the time is, so I'll say b, just for lack of a better letter, of your payment stream. Now, think about how we did present value. Before I put, this is not the total thing, obviously, because I just told you there's two integrals, right? Okay. But think about what we did for present value when we had continuously compounded interest. You did the accumulated value, and you multiplied it by e to the negative delta t, right? Okay. So that same kind of thing is going to happen here. This integral from 0 to b would give you your accumulated value. right? Do you agree? If payments are coming in this way, I'm not without regarding interest at all, right? If I had a payment stream that was coming in like this and I integrated, that would give me total amount of payment, right? Agree? All right, so then if I want to do that total amount, I'm going to need to multiply this by e to the negative something. The way this goes is, well, at a particular point t, I need to move that payment back from time t to time 0, right? At a particular t, if I think about this value, I've got to move it backwards from time t to time 0. But when I go to a new t, I've got to move it a different distance, correct? Right? Think of it this way. If I have a payment at time 1, I've got to move it backwards from time 0 to time 1. Or from time 1 to time 0. Time 0 to time 1 is not backward. Right? But if I've got a payment at time 1, I've got to move it backward from time 1 to time 0. Correct? But if I have a different payment at time 2, I've got to move it backward from time 2 to time 0. Right? Now, all these things are changing continuously. Right? So if I'm at time t, I've got to move that payment backward from time t to time 0 and add all this stuff up. So what happens in your exponent is you end up with an integral from 0 to t, because that t has to change. You agree with what I'm saying? As this payment changes by time, the time I have to move it backward changes. Right? So this upper limit of integration here is varying with respect to t. And then I got to integrate my interest function. And I'm going to change the variable name because, remember again, this variable up here has nothing to do with this variable in here. Right? This is the variable of integration, and I'm going to put this variable in it. And then I'm going to integrate this with respect to t. So this is why it's not a double integral, because one of the integrals is up in the exponent. Okay. I know, it's ugly. I agree.
It's not that much more easier.
Yeah, and the good news is the problems are rigged so that the integrals are easy.
And I'm okay with that.
Yeah, or you might do an integration by parts, but typically they're rigged. They're typically rigged so they're either a substitution or the e goes away. You see a lot of natural logs in your integrals, for example. Okay. Because you do e to the log, they'll go away. All right, so let's do this one. See if I can move this down. Oops. I drew instead of selected. Maybe. I'll just drag it with my finger. Just clearly dragging it with my... I can make it really big if you want.
Dramatic.
Is that what you wanted? All right. So this is probably 9.10 in your book. Force of interest at time t is that function, 1,000th t cubed. You want the present value of a 4-year continuously increasing annuity. This is not good language that it's using because continuously increasing annuity typically means one very specific thing that we'll have another formula for. So because continuously increasing annuity typically means that the rate of payment is t. I mean, it is continuously increasing, but the rate of payment is not t. If the rate of payment is t, we've got a formula where you don't have to do any integration. Okay, works out nicely. All right. So here's this part right here. Oops, I'm still on select. This part right here is your delta of t. This part here is your payment at time t. It's a 4-year continuously increasing annuity. So if I want the present value then, we'll integrate from 0 to 4. So integrate over the whole time period. Integrate the payment, which is the payment stream, which is 3t cubed. Again, thinking of it just kind of intuitively, if I integrated the payment stream over the entire interval, that would give me an accumulated value, right? So I have to move it backward for present value, which is why we got that e to the negative integral in the next piece, right? That's how we find present value, right? We work off the accumulated value and move it backward. So it's the same kind of concept. E to the negative integral from 0 to t. Again, I have to keep this upper limit variable because at different times I have different payment amounts, right? So I have to move it back a different distance. Does that make sense? This is, the 0 to t is the distance that you have to move back this payment amount at time t. And then the delta of s would be 0.001 s cubed ds and then dt. The s doesn't, I only used s because the book used s. You can use whatever letter you want there besides t. And actually, technically speaking, if you want to leave it as a t and know that you're going to just plug the t back in for t, you can. It just looks ugly. It looks like the t means the same thing when it really doesn't. What were you saying, Hannah?
I'm using capital T.
You use it?
The lowercase t.
That's fine, you can do that. That's perfect. Whatever keeps it straight for you, it doesn't really matter.
That would confuse me.
That would confuse you? I think you should use a T, a capital T, and a tau.
I don't know how to draw a tau.
It looks like a T, but it's just a little curly thing on the bottom. Like, oop, maybe. Like that.
Looks like a backward.
Yeah.
I'm gonna use an uppercase.
That's a lowercase tau.
What's an uppercase? I don't think it's a big T.
I think so, yeah. Taus are weird looking.
Why does everyone draw a towel differently?
I don't know. Why do we use a XE or a Xi or whatever the heck it is? This one.
What?
I've never used that before.
That's a Greek letter, yeah.
That's sweet.
It's the one right before Omicron. XI. So it's the letter before Omicron. Xi, Omicron, Pi, Rho, Sigma, Tau, and
Do
so
you know
on.
all the Greek letters?
Yeah.
Can you sing the Greek ABCs?
Yeah, say them.
Can you say them?
Can you sing?
Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, nu, Xi, Omicron, Pi, Rho, Sigma, Tau.
What was the middle one?
I kind of drunk slurred over that one. Remember this, right? Yeah. I was trying to say it.
That in proper frat boy fashion.
Yeah.
Does Dr. Joe a frat boy?
I worked 50 hours a week. I didn't do anything besides work and go to school.
I don't understand. So, is there like a certain convention for certain Greek letters? Like epsilon, like is always used with like small space.
Yeah.
I feel like and
Yeah.
deltas are always chanted.
Yep.
Is there other letters like that?
Like that. Yeah, kappa is for curvature. Alpha, beta, and gamma are used for angles a lot in theta. What is nu used for? Nu is. What does mu is mean? Nu is.
Phi is angles too sometimes.
They use that. They use nu in. No, not nu. They use eta. Eta in economics. Elasticity, I think, in economics they use eta.
What does it look like? Is it just
XI.
a big E?
How do you say that?
And Xi. That's how I pronounce it, but
I don't remember.
it's
if it was-
sh. Yeah.
I don't remember if it was you or Dr. Olson told us about a conference that you guys went to where they use like really weird Greek letters just to mess with everybody.
Cool. I like it.
Lowercase zeta is really funky too.
Zeta.
Yeah, lowercase. It's like a C with a curly Q and like a.
Dr. Joe knows it.
Yeah, that one.
Mm-hmm. I've used them all on a math problem at one point or another.
Lowercase eta looks too much like pi.
Eta. It looks like this.
Lowercase
Well,
tau.
on this picture, it looks like pi a lot. It's like not. It looks like.
I can draw that one too.
It looks like.
It's kind of fun.
But
All
I don't know,
right.
it looks,
That
it
kind of
just
looks like a
looks
mushroom. Which one? Your pie.
My pie.
How come there are two versions of lowercase?
What letter is that?
I think you draw an eyeball, the middle of the top one.
Do you like mushrooms, Dr. Joe?
Do I like mushrooms? No, not particularly.
Oh, I don't know.
Dr. Joe, one more question about the gap. Why on this thing there are two lowercase sigmas?
There's two lowercase sigmas. This one and what else?
Like zeta, but without the curly Q on top. Like a C and like a with a little.
Like that?
Yeah.
Yes.
That looks like an S.
Well,
I don't think I've ever.
It doesn't look like an S. Like it looks like a.
Guy I've worked with in the past calls this tornado.
That's what
he calls it in talk. Every time he says tornado, some eye or whatever.
It's like a like that.
It looks like a that looks like a French.
French C.
Yeah, Frenchy C.
Dr. Joe, they replaced the chalk. You can break lots of chalk.
I think you can. That's just weird.
There's two.
Yeah.
What?
That has to be the 45.
Oh yeah, it would. Thanks.
Take mark.
It is another tick mark. I know.
Alrighty. Your oh, I can't say that.
That's like,
What were we gonna say?
I can't say it.
Can't say what.
It's on the test. I can't say it.
Oh.
Yeah, I was gonna make that joke too, Grace. I know exactly what I'm
No, I know what you're talking about.
Probability joke.
It's probably a joke.
Can't get it. Sorry.
We agree?
Yeah.
Okay, so now notice that you're gonna use substitution, right?
We will. Yeah, we will.
I was just gonna do integration by parts.
Yeah, I wouldn't do the inverse by parts.
Would be ugly. But
It wouldn't be. It was a use substitution, right? Because if I take the derivative here.
I
What?
see it now. Yeah.
Marshall's not too great with you, so.
Oh. 4t cubed, so we get the t cubed that I want. So you would need to do. What would you need to do? I would need to do 3 over. No, I need to do a 3,000, I think.
Why'd you take me down?
Well, if I multiply that by 4, when I do 4t cubed times this, I get 1,000th, which I would have to divide by.
Can you go through and set the U up inside?
Oh
just
my
for me? 'Cause I'm
gosh.
struggling to see it right now. My U sub is a little bad. Thank
Oh, you
Dr.
took it out
Joe.
before. Okay, I left the .0025
Okay,
in there.
I see it now. Okay,
Yeah?
perfect. Thank you.
So I'd have to divide by negative 1,000th, or multiply by 1,000,
So why is it 3,000 and not 1,000? Because the 3.
because the 3 in here. There's a 3 here that I pulled out in front, and then I divided by 1,000th.
I could.
What'd you do?
I left my .00025 in the integral and just did my t to the 4th as my u, and so I got 3t.
Okay, so you're still gonna have
I would still have
you still have a 4. You're gonna have a 4
4
out in front, right? Or a 1.
I'll figure it out. You just we got it.
Would it be easier to do a new limit here, or to just substitute back in your U?
It probably would just be easier to substitute back in, but I don't think it really matters.
Yeah, I was curious.
I think the top is going to be negative .00. Oh no! Wait a minute. It's not. 4. It's 4.64. I think. When I multiply by 4, we got .00025 because we divided .001 by 4 when we did the first integral. So if I multiply by 4 again, it's going to be .001 times 4 cubed, 64. I should get .064. So calculators are 4.
Clever mental math right here.
You gotta remember when I went to high school, we didn't have a lot of calculators floating around, so you had to do a lot of arithmetic. What's that? What'd you say?
I said they floated around.
They did. It's amazing.
Did you go to Hogwarts or something?
Yeah.
Did I go to Hogwarts? Yes, absolutely. I went to Hogwarts.
Dr. Rockwood appreciated that too.
It is true. I've never watched Harry Potter, so.
There is something
I never
wrong.
watched
Yeah.
In the car, I asked there was a guy who presented on a recommender for like movies,
Mhm.
and Dr. Joe doesn't think he's watched 15 to 20 movies, but what, the last 10 years, he said?
Probably not. Definitely not in the theater. Absolutely not.
Did you go see Joker?
No.
Oh,
It wasn't very good.
I thought it was good.
I did not like it. That's boring.
So you can't appreciate it.
Last movie I saw at the theater, I think, was the latest Jurassic Park movie that came out. What was it? A couple of years ago. It was
That was
not
last
good.
summer.
Was that last summer?
I didn't
Yeah.
see that one.
It wasn't very
I
good.
saw that one.
It was not very good.
No.
They made a good
They
one.
should've just
a lot.
stopped.
It was just, how can we throw a bunch of dinosaurs in here?
Yeah.
Because none of it made any sense.
You know what?
It's okay?
I've just kind of always had this thing.
Does the process make sense? Are we happy?
Answer this stuff.
And like other problems, we started this at 0 to go back to the present value at time 0, but you could start this at time whatever you wanted to. And it was just both of those lower limits would be the same starting point. So if you started at 2, you would do the integral from 2 to whatever, rather than 0. It's the same formula every time. It's okay? And like I said, most of the integrals are rigged. Either you're going to do a U substitution at this point, or you're going to do a, lost my train of thought. That'd be a natural log. I'll just get rid of the E. I said that earlier, and then I lost my train of thought what I was saying. So let's do another one. Let's see if I can find one. I forgot where I copied it. All right. Let's do this one, because it talks about the, what are we doing now?
Why do you have the pages labeled? Doesn't that drive you crazy that they all say untitled?
No?
Well, then, if they were like labeled, you could be like, oh, 9.03 is in this one.
Yeah, that's more sophisticated than I. Well, I don't usually. You know how I got these in here? I held the book up with one hand and took a picture off the surface with the other, and then copied and pasted it over. That's why if you look at it, it's kind of skewed and stuff because the book was bent.
Couldn't you just, like,
Well, I would have had them like that. Yeah, but that would have had to get them out of the chair.
I would have done the same thing. Dr.
You
Joe.
you would
I
take
kept
it on
lying.
your phone and emailed it to yourself.
Yeah, but this was already on my surface. My phone was in the other room.
It was like the least amount of most effort he could possibly.
That was right.
Probably more effort than it really would have been.
Yes,
He
it's
didn't have to
like
get out of the
taking
chair.
longer.
I would have to get out of the chair, so screw that.
Before you took the service.
Yeah, but then he has to find the camera thing to plug in the surface. I know exactly what Dr. Joe means.
The person who takes more time making an excuse not to do the homework than it would take to do the homework.
Yeah, absolutely. That's exactly what that was. But I got it done. I wanted to put it up here. So, all right. Anyway, so I wanted to do this particular one because it's an example of the type of thing that I was mentioning at the beginning of class of the different words. So this one. The perpetuity, anyway. So it's a little bit different. Is this one I wanted to do first then? It's fine, I'll do this one first. Doesn't matter. In this case, the payments are being made continuously at a rate of t. So this is what the book refers to as continuously increasing annuity. Or in this case, continuously increasing perpetuity. Okay? Because the rate is t. Now, to make the formula work that we're going to talk about, this has to be a constant interest rate. Okay? So when we talk about a continuously increasing perpetuity or annuity, what we mean is that the payment at time t is some multiple of t. So I'm just going to do it at t right now. Okay? And your force of interest is constant. Okay? Now, notice that if you did this, I'm going to write it on the board because I'm not going to write. I don't care that you write it in your notes. If you were going to do this using the definition we just talked about, you would do the present value would be the integral from 0 to b. Your payment is t, right? Since there's a constant force of interest, when you integrate from 0 to t, you'll just get delta t, right? So you'll get e to the minus delta t dt. Yes, Haley?
Never mind, I think you said that. So I gotta write it down a different way because it'll confuse me when I look back later. The delta dash constant is saying the delta is a constant,
Delta is
not
a
delta
constant,
minus constant.
No,
Okay,
the delta
right,
is a
right.
constant.
That's how I'll study it later. I'll get.
How's that? Okay. All right, Marshall, what technique would you use for this one to integrate?
I would use integration.
I would use integration by parts as well, okay? So if you didn't have the formula, that's what you would need to do at this point, to be doing integration by parts. And if for some reason this came up on the exam and you forgot the formula, you could do it by parts.
There's a formula?
There's going to be a formula, yes.
So I don't have to do integration.
Correct, if you remember the formula, which looks a lot like the formulas that we've already talked about. So the formula for this, what's wrong?
Slight change.
So of course it does.
It has a formula with a slight change.
Looks just like the other one.
It's an IA with a period after the A.
No, it's not a period.
No.
That was just a skip of the pen. This one has a bar over the A and a bar over the I.
They couldn't come up with something new.
No, you probably couldn't possibly come up with something new. That's crazy.
It might be easier to integrate by parts at this point.
All right. So this is the IA double bar angle N. It's just dumb. I know.
It takes longer to say like the formula than it does to like use the actual formula.
All right. So what was your formula for increasing annuity?
Double dot.
Any double dot angle N
Minus.
minus
V to the N.
N V to the N
All over.
all over I. Good. If we change that to If we change it from IA angle N to IA bar, just the bar over the A, what changed about that formula? It was force of interest in the denominator, but it was still A double dot in the numerator, right? All right, the change that happens here, it's A bar, yep, it is. It's A bar,
You watched the videos, didn't you?
No, I didn't. Nice guess.
angle N, minus NV to the N over delta.
Picked up on some context clues. I got through Spanish.
I know, it's kind of weird, isn't it?
Anybody remember what A bar is?
What's that?
Always takes off.
Nope. What A bar is? You don't remember what A bar is?
It's 1 minus V to the N over delta.
It's 1 minus v to the N over delta.
Oh, it's just the delta.
It's just the delta part, yeah.
But we can't put that into our calculator.
Correct. You have to do that one by hand, yeah, or by hand. It's not a time value money one.
Man.
Actually, you can. You can. You can do, because your A bar bracket N is your A angle N. You would multiply it by I and divide by delta. Because this formula has an I at the denominator, right?
Yeah.
So I can just multiply by I and divide by delta, and so you can use your time value money buttons if you want.
Interesting.
That would be one.
Yeah.
It's a very nice conversion.
Isn't it a very nice conversion?
I feel like it'll be useful one of these days.
All right. Now, this problem asks for continuously increasing perpetuity. So how do you think the formula is going to change? The notation is pretty obvious how it's going to change. An infinity symbol, right? All right. And then I'm probably going to get an infinity symbol here too, right? Probably. And then what's going to happen to this term? It goes to 0, right?
Mm-hmm.
The reason for that is, if you really wanted to, you can use L'Hopital's rule, but v is smaller than 1, so really you have a fraction, right? And the exponentials always beat polynomials to infinity. So you've got polynomial over exponential, so it's going to go to 0.
That's
My
0.
thinking was that V is 1 plus I is -1.
Right.
And then so that means 1 plus I is then it's negative.
Yeah, it goes to 0. It's just technically you got an n out in front too. It's going off to infinity. So you got infinity times 0.
Yeah, but
Yeah, you just ignore it. Which is good because in this case, because exponentials beat the polynomials to infinity.
yeah, see, like I knew that. I just
Yeah.
didn't want to like
Yeah, you didn't want to.
use it.
Yeah, gotcha. Do we remember the formula for this one?
I just said it.
This one?
Oh, no, I didn't.
That one.
1 over force of interest times t.
1 over force of interest? So you think does it look like that?
What is this?
A bar infinity.
A bar infinity?
X over delta D.
Delta D?
I think so. I definitely have it delta D written down.
Okay, well, it could absolutely be delta D. Sure.
What is this?
I don't know.
Yeah.
Off the top of my head, I don't know.
Oh, the whole thing simplifies to. I thought we were talking about A bar.
Yeah, so you did. Yeah. So there was an extra delta on bottom, right?
Right.
So it should be delta squared. If A bar infinity is 1 over delta D.
I'm not saying that it is. That was my guess. It's x times 1 over delta times d.
Okay, well there you go. So in this problem, what do we need to do? Find, and what did you find delta? What's delta? 1.05, and you would do natural log of that, like Marcel said. That would give you your delta. And what else do you need? That? Is that what you said?
Yeah.
I over 1 plus I? Yep. Okay. And then you just plug it into that formula.
Is that what it is? Is that what d is?
I over 1 plus I? Yeah.
So we don't need the payment at all for this problem?
Well, then you'll have to multiply by 3, yeah. Because the formula is assuming payments of 1.
Okay.
Or the coefficient in this case is 1.
Okay.
You would have to multiply by 3.
Wait, what? Where's the problem?
Chris, what'd you get?
Does it look like I touched my calculator?
I don't know, you're pretty sneaky.
I definitely did not get that.
So why do we have to continue
Why you have to do what?
to do a bar? I'm confused why we have to multiply by 3.
It's 1 over delta. And I have 26,000.
Why do we have to multiply by 3?
3t. It's not just t. The formula is for t, so it's just 3t.
But that's the simplification. Times the whole thing.
So 3 over delta squared. Square natural log.
No, it's interesting. We're squaring the whole log.
My exponentials are not fast.
Ooh, I can now get that dollar.
What did you get?
Like 24,000.
I got 26,000. I got 26,000.
I got 1291.
What did you type there?
We divided by delta times d.
Okay, let's not be d squared then.
My buttons.
Delta what?
This must not be. This might not be squared then.
This is calculated buttons.
It must just be delta d and not just. What's that?
That's all I got. Close.
And then I just tried to hit the payment button to just get a payment.
Yeah, I got 1291.24.
Oops.
So it's not
You can fix it. I'll owe you one.
But now why isn't it delta squared?
1291, 24.
You're right, your payment button doesn't work.
I don't know if I can get a warranty on
Why
it.
is
Like,
it?
a refund on it, because I haven't even had it for half a year. It's kind of BS.
There's no book, you already wrote the buttons off.
I think I
That's the right answer in the back.
That's why I'm confused.
Future value?
I did this problem before I came into class, I promise. Yeah, because it must not be that either. Yeah, because it's supposed to be D. This is not delta. This has to be.
It's like the,
It should be 1 over delta squared, is what it should be. That's what I thought it was supposed to be.
yeah.
No D?
No D. No, it should be 1 over delta squared. So 1 over delta needs to be the.
It's just not useful.
It's been a while since I thought about the continuously paying perpetuity, but this should be 1 over delta, not 1 over D times delta.
There's something
Oh, maybe.
No, because mine said that too.
It's D over.
It's on the videos.
Well, I think
So there's no D in it?
Oh, not the continuously one.
No, there's no D.
We're doing. It's not continuously increasing.
Oh, it's just.
It's just continuously paying annuity.
Oh, okay. That's.
So 1 over delta?
That's why it wasn't done. Yes, if it's continuously paying increase in annuity. Sorry, try again. Continuously paying increase in perpetuity is 1 over delta times D. This is just continuously paying annuity.
Oh, that's nice.
I got 1260.5.
Yeah, I got 1260.25.
What have been in this region?
This is what it should be.
It wasn't on the first exam.
Let's see. On my good calculator.
I have it.
We didn't do it. Maybe you did
There's
it.
the answer. Is it 1260?
No, we
Here we go. You're getting closer.
We didn't talk about it, we just talked about immediate. Cause I remember watching the video and being like, what the heck is a continuous?
Maybe we just didn't do it.
We must have that. We must have another continuous one. We can get the formula though pretty easily, I think. If you know your regular perpetuity, well, your regular annuity is this, right?
Yeah,
We agree?
throw back to those days.
Go back to those days. If you let n go off to infinity, this is going to go to 0, right? So I get that 1 over I. That's why this is this one, right?
Yeah, that makes sense.
Right? Continuously paying level annuities look exactly the same, except there's a delta on bottom, right?
Yeah.
So again, as n goes to infinity, this goes to 0. So So your a bar infinity is 1 over delta, because that part's going to 0. There wasn't a d in front. The d came from the increasing in part. So my apologies. I should have looked at that before right before I came to class, rather than looked at it a couple of days ago. Sorry. I'm sorry.
Just another tick mark.
Dr. Joe,
Yes.
Grace.
I'm gonna count.